Okay troops, going to give you a little walkthrough of a mixed series and parallel circuit. I've designed a wee circuit here with 3 parallel resistors and 2 series resistors, and we're going to work out current and voltage all over this wee circuit. And here's a typical way that you're asked these questions. You have to calculate the total resistance of the circuit, then you have to calculate the total current that comes out the battery, and then using that total current you have to calculate the individual voltages across each of the series parts of the circuit, and then finally the current in one of the parallel resistors. So total resistance, total current, individual voltages, individual currents. First thing to do then is simplify the circuit down to a single resistor. And what you would obviously do first then is you would look at the parallel bit of the circuit, and you would use your resistors in parallel equation from National 5 Physics and work out the total resistance of the parallel bit first. Now remember, there's your resistors in parallel equation from National 5. So 1 over 7 plus 1 over 14 plus 1 over 28 gives you 1 over 4, but remember to flip it, and the total resistance is 4 ohms. Then we can simplify our circuit down. We've worked out the middle parallel bit as a single resistor, so let's redraw the circuit with 3 series resistors here. So our middle resistor was 4 ohms, and our left hand one was 20 ohms, and the right hand one was 26 ohms. And now that we've got 3 series resistors, we can very quickly work out the total resistance because they're all in series, and when they're in series you just add them together. So the total resistance of the circuit is 50 ohms, and that was the first thing we were asked to do, was calculate the total resistance of the circuit. So there we go. Now part B, we have to calculate the current that comes from the battery. Well, let's simplify our circuit even further, and let's just draw a circuit with a single supply and a single resistor. Now we know it's a 12 volt supply, and we know it's a 50 ohm total resistance of that circuit, and then it's just a case of using Ohm's law to work out the total current. I equals V over R, which is 12 over 50, and if you do that on your calculator you'll get 0.24 amps. That's the total current drawn from the battery. Now we could add that onto our diagram right back at the very start. So we've worked out the current from the battery. Let's add it on there because 0.24 amps will come out the negative terminal of the battery. Now next part, what we have to do is work out the individual voltages across each of the series resistor sections. So there's our simplified version of the circuit. I've just copied it from above there, and we have to work out how much of a share of that 12 volts each of those series sections gets. Remember, we're just going to use Ohm's law again because we know what the total current is that's coming out the battery. We've just worked it out, and that current was 0.24 amps. So using that current, it's just a case of using Ohm's law individually with each section, and the 0.24 amps with each resistor, and working out the individual voltages. So 0.24 times 26 is 6.24 volts. And as a wee check, let's add all them together. 4.8 plus 0.96 plus 6.24, and that gives us the 12 volts, which is the total voltage, the supply voltage. So now we've calculated the voltage across each section. We were asked for the voltage across the 26 ohm resistor, which was 6.24 volts. Now, part D then, we have to calculate the current in one of the parallel resistors, the 7 ohm resistor here. So Let's redraw this circuit again a little bit further down the page, because that's what we're interested in, the current through the 7 ohm resistor. So we know the total current coming out the battery was 0.24 amps, but that current's going to split in the parallel branches, and that parallel section has got 0.96 volts across it. We calculated that earlier, and it's that voltage that we are going to use to work out the current through the 7 ohm resistor. So 0.96 divided by 7 gives us a current of 0.14 amps. Now we could work out the current in the other 2 branches as well. So in the 14 ohm resistor, it'll be the same voltage, 0.96 over 14 is 0.07 amps. And in the 28 ohm resistor, 0.96 over 28 gives us 0.03 amps. And again, you can check here, if you add them up, those individual currents, they should add up to the current, the total current that comes from the battery, 0.24 amps. Let's build the circuit and check it using the PhET website simulation. Let's have a look. Right, I have rebuilt this circuit. Let's show the values just to show you that the battery is 12 volts and all of those resistors are the same as they are in the wee circuit I designed. And we want to measure the total current coming from the battery. It should be 0.24. There we go. It's 0.24 coming out the battery, 0.24 there, and there. It's 0.24 everywhere, apart from the parallel section. What about the currents in the parallel sections? Well, we'll check them in a wee minute. Let's do the voltage first. We were asked for the voltage across the 26 ohm resistor. We got 6.24 volts, and there you go, 6.24 volts. I want to check the other 2 voltages. There you go, across the 20 ohm, 4.8, and across the parallel branch, we got 0.96. There it is. And there's 0.96 volts across each of those parallel resistors. Remember, in parallel, every resistor gets the same voltage. So each one's getting 0.96 volts. Let's put the voltmeter away, get that ammeter back out again, because we want to measure the current through the parallel branches. 0.14 was what we got, 0.07 and 0.03. Add all them up and you get 0.24 amps. So there you go, check your circuits, build them on the PhET simulation, have a wee resistor party. Now, what about power? I haven't mentioned power. We did a lot of calculations with power in National 5, so you could also be asked to calculate the power dissipated in any of the resistors. Now, dissipated just means the energy transferred per second, or the power that's produced in it. Now, we have 3 power equations from National 5. Which one will we use? Well, it depends what numbers you know in the question. If we're asked to calculate the power in the 14 ohm resistor, well, we know its resistance and we know the voltage across it. We calculated the voltage across that 14 ohm resistor and it was 0.96 volts. It's in that parallel branch, but each of those resistors gets 0.96 volts. So 0.96 squared divided by 14, and that will give us the power dissipated in the 14 ohm resistor, 0.066 watts. Now you could have used the other power equations, but you would have had to have worked out the current first. Remember, I equals V over R, 0.96 over 14 would give you the current in the 14 ohm resistor, 0.069, and then if you substitute that into P equals IV, then, surprise, surprise, you will get the same answer, 0.066 watts. So, that's mixed series and parallel circuits. Bear in mind you should be able to do some circuit analysis on that, working out current, voltage, resistance, and power. We'll see you in the next one.